All right, so the first few problems are from the review packet, and the last problem is from the homework packet. The last one is not going to be on your quiz, but I figured I'd do it anyway because someone asked. So number 18 from the review packet says, in a parallelogram DEFG, DH is x plus 3, HF is 3y, GH is 4x minus 5, and HE is 2y plus 3. Super important to label your diagrams to help you through this. Then it says find the values of x and y. Well, since this is a parallelogram, in a parallelogram, the diagonals bisect each other. So these two are congruent and these two are congruent. So I can set up the two equations. 3y equals x plus 3. And I could set up the equation 4x minus 5 equals 2y plus 3. Notice you have x's and y's in the same equation, so it looks like you're going to have to solve a system of equations here. Something you should know how to do by now. So I'll just do this one quickly. I'm going to solve using elimination. So I'm going to get each of these into standard form. So for this one, I will have x minus 3y equals negative 3. And for this guy here, I will have 4x minus 2y equals 5, 6, 7, 8. To make this a little bit easier to solve, I'm actually going to divide this whole thing by 2. So I have 2x minus y equals 4. And then I will multiply this equation by negative 2 to give me, and I'll write that right underneath here, negative 2x plus 6y equals 6. I'll add those cancel. I have 5y equals 10, so y equals 2. All you then need to do is plug this into one of these two for solving for x. Again, I could do that quickly. 3 times 2 will be 6 equals x plus 3, so x equals 3. And there you have that one, okay? Next one. So I did work ahead of time on this one just to save time on this video. You were asked to determine the most precise name for the quadrilateral based on information from its diagonals. So in a quadrilateral, depending on the type, the diagonals could be perpendicular, the diagonals could be equal, they could bisect each other, and each of those things you can find out based on the length, based on the location of the midpoint, and based on the slope. So in the first one, I found the length of each diagonal. They are not the same. Okay, so since the diagonals are not the same, I know that this is not a rectangle. It's not a rectangle, it's not a square, and it's not an isosceles trapezoid. Let me just write the names down. So we have your basic quadrilateral. We have a parallelogram, L-O-G-R-A-M. We have a rectangle, rhombus, square, kite, isosceles, trap, and we have a right trap. Well, I'm not going to include this here. I would be very specific on this. I'm not going to include a right trap here because based on the diagonals, it'd be difficult to tell the difference between a regular trapezoid and a right trapezoid. You would need more information, so I guess I'll include it. Right trap. And then we could talk about it if we come to that issue. So again, because these diagonals are not the same length, we can cross out the idea that this could be a rectangle. So it can't be a rectangle, it can't be a square, and it can't be an isosceles trapezoid because the diagonals are congruent in those, and here they're not. This tells me very interesting bit of information that the diagonals are actually perpendicular to each other, okay? A line that it has an undefined slope is a vertical line, and a line that has a zero slope is a horizontal line. So these are actually opposite reciprocals, giving me perpendicular diagonals. So that means this could be a rhombus, or this could be a kite that actually gets rid of parallelogram, regular old quadrilateral trap, and right trap. It has to be one of these two because the diagonals are perpendicular. Then, because the midpoints are different, let me just double check here that I did this correctly. That'll give me, yep. So my midpoints are 6, 6 and 6, 8. So since the midpoints of the diagonals are not the same, this has to be a kite, okay? If the midpoints of the diagonals were the same, then that would tell us that the diagonals are bisecting each other, and therefore we have a rhombus. Since they're not bisecting each other because these are not the same, it has to be a kite, okay? So I'll go and kind of do the same thing in a different color for D here. I'll make D red as I go through. So here, again, diagonals are not the same length, okay? So let me just double check on that BD there. I feel like that looks funky. So 1 minus -7 squared plus 7 minus -3 squared. Oops, I forgot my plus sign. 164. Yeah, that's correct. So since these are not the same, that allows us to get rid of rectangle, square, and isosceles trapezoid again, because in those the diagonals have to be the same. Now looking at the slopes, they have no relationship to each other. They're not opposite reciprocals, they're just kind of one's positive, one's negative. But since they're not opposite reciprocals, we can eliminate a rhombus and a kite, because in those they have to be perpendicular, and this is telling us that they are not perpendicular. Now lastly, we have this bit of information here. Okay, this is telling me that the diagonals also don't bisect each other because these midpoints are not the same. So that takes away parallelogram. So our possibilities here are just a basic quadrilateral, a trapezoid, or a right trapezoid. Now for your quiz, I'll give you probably a list of options. I'll say, is this a parallelogram, rectangle, rhombus, square, kite? I probably won't include basic trapezoid or basic quadrilateral, and I probably won't include right trapezoid. So if I didn't include these two, this would absolutely be a trapezoid because none of this information really tells us that it's a special quadrilateral, okay? But for us to determine that for sure, we would need more information, especially about the sides. Again, this was based off the diagonals, so this one was a little bit more difficult, but it'll be a more concrete example on your quiz if there is one like this. Okay? This is the same idea, but you're doing it based off of the sides. So again, I did some front work here so that I had the information all ready to go. I'll do the same thing I did before. I'm going to leave out basic quadrilateral and just write this special quadrilaterals because that's really what we're looking for here. Parallelogram, rectangle, and again, I'll be more precise on your quiz as to what I'm looking for. Square, isosceles, trap, regular trap, kite, and right trap. Okay, so we will do the one on the left in blue again. Okay, so what I'm noticing here is that I have opposite sides that are congruent. Opposite sides are congruent. So if the opposite sides are congruent, it has to be some type of parallelogram, right? We can cross out right trap, kite, trap. Oops, I should actually cross these out. Right trap, kite, trap, isosceles trap. It's not a square because all four of them are not the same. And it's not a rhombus because all four of them are not the same. So really, this just comes down to parallelogram and rectangle. And we can tell what each of those are based on the slope. The slope of a rectangle has to be opposite reciprocal for its sides. These are not opposite reciprocal slopes. Therefore, the figure for number 24C has to be a parallelogram. Again, I will do D in red. So we noticed, looking at the sides, that they are all the same. So we can get rid of a lot of options here. All four sides are the same. It's not a parallelogram. It's not a rectangle. It's not an isosceles trap. It's not a trap. It's not a kite. It's not a right trap. It has to be either a rhombus or a square. What makes these two different from each other? The sides of a square have to be opposite reciprocals for the slopes. I have slopes of 1/5 and -5. These are opposite reciprocals of each other. Therefore, we have a square, not a rhombus. Okay? Obviously, you can graph it to double check, but on the quiz, I would expect to see this work done out. Okay? All right, number 25. The following figures are parallelograms. Find the value of the variable. I am told NS is 2x plus 7, and I'm told SQ is 5x minus 23. Again, we just talked about this. In parallelograms, the diagonals bisect each other. So these are the same. 5x minus 23 equals 2x plus 7, and I think you guys can take that one from there. If I had it wrong on my answer key, I apologize. I told you this before, I do them quickly, and I am only human, so I am bound to make mistakes. Okay, 32. EFGH is an isosceles trapezoid. I'm going to move this over a little bit. EH is 4x minus 27. FG is x plus 9. EG, this diagonal here, is 3y plus 19. So this is 3y plus 19. And FH, this guy, is 11y minus 21. Okay, since these are the parallel sides in this isosceles trapezoid, these two sides have to be congruent. So that's your first equation. 4x minus 27 equals x plus 9. That's equation number 1. I think you can guys have that one. Since it's an isosceles trapezoid, the diagonals are congruent. So your other equation, 11y minus 21 equals 3y plus 19. Relatively simple. So you need to make sure that you know the properties for each of these, because in the end, that's what it comes down to. Do you know the properties? Do you know them well enough to set up and solve your equations? Solving you got. It's the setup that's the tricky part. Okay? 6. We have a kite here. I wish the directions said that this was a kite, but it's definitely a kite. That information is important, especially when I've told you in the past that looks are deceiving. You cannot go based on what the diagram looks like. So this is, in fact, a kite. RS is 10. RU is 9. We want to find QS. Well, in a kite, the diagonals are perpendicular. So this is just a classic Pythagorean theorem. Diagonals are perpendicular, and these are going to be the same. Because in a kite, the diagonal that cuts through the non-vertex angles, gets bisected. So this is split in half, therefore these will be congruent. So if we use the Pythagorean theorem to find this guy, we just multiply it by 2 to get the whole thing. So 10 squared minus 9 squared gives us, did I do that right? 19. And the square root of 19, well, is we don't actually know. So we're just going to leave it as the square root of 19, right? So all we have to do is square root of 19 plus square root of 19 to square root 19. Woohoo! Easy peasy. Lemon squeezy. Okay, finding the missing coordinates here. If you looked at the stations, it said also find the midpoints, but when I looked at this again, the midpoints just took a lot of work. So we just got practice finding the missing coordinates on this one. So for this isosceles trapezoid, okay, I went for A, I went a whole n units to here, and then I went n plus 1 more to get from here to here to R. So that means this is 1. That has to be the same on this side here. But since it's moving in a negative direction, we're going to call it -1 when we subtract it from P. So this is negative P. This will be negative P minus 1. Okay? This is at the same Y value as R. Therefore, this will be a K. And this down here, P, is at the same Y value as A. So that will be negative M. For the rhombus, remember the diagonals in a rhombus are perpendicular bisectors of each other. So that's where this information is going to be helpful. These are perpendicular bisectors of each other. Okay? So to get to here, if this is at 7A, we're going to split it in half to get these two, 7A over 2. And obviously this didn't leave the x-axis, so it's at 0. Same thing is going to happen going in this direction, okay? If this, to get to here, is 5C, we're going to split it in half to get to here and here. So we have 5C over 2, 5C over 2, and then obviously, again, this one did not leave the y-axis, so 0. Okay? And the last problem, again, there will not be something like this on your quiz, but it looked like fun, so why not do it? We're given ABCD as a parallelogram, and we're given AP is congruent to QC. Oh, a proof, so much fun. We want to show, I'm going to put what we want to show in red here. We want to show that AC and PQ bisect each other. So in order to show that, we want to show that RC is congruent to AR and QR is congruent to RP. Let's do this to make it correct here. Okay. So that's eventually, we should probably get there before we get to the fact that they bisect each other, because that proves that they bisect each other. Okay, so it's a parallelogram. I guess we can call this a given. Technically, we would call that the definition of a parallelogram. Opposite sides are parallel. So therefore, since these lines, DC and AB, are parallel, this information is saying APR, this angle here, is congruent to CQR, this angle here. Okay, and that would just be alternate interior angles theorem. Okay, oops. And then this one is asking us to using the alternate interior angles theorem. Again, AIA, alternate interior angles theorem. Again, so what would I do to use this again? I would say this angle is congruent to this angle here. So angle PAR is congruent to angle QCR. And in fact, you guys couldn't actually complete this one yet because of this information right here. I can tell that we haven't gotten there yet. We're actually getting there after this quiz. So you wouldn't be able to do this one anyway. But I'll keep going. So with these two sets of angles being congruent, and the fact that we know these two sides are congruent, that is our other given right here that that's referring to. AP congruent to QC. This information allows us to determine that these two triangles here are actually congruent. They have the same angle measures and the same side lengths. So APR, triangle APR, is congruent to triangle QCR, and that's by angle, side, angle. Okay, we had an angle here, and then the included sides congruent. Again, this is something you're going to learn. It's a nice little preview for what we have to come in the next weeks. So because these two triangles are congruent, we can prove that AR is congruent to RC, and that's by something called CPC-TC, again, something we will learn next week. And we can say QR is congruent to RP, again, by CPC-TC. Since these two things are congruent to each other, these are congruent and these are congruent, we can tell that this is bisected by QP and QP is bisected by AC. Therefore, they bisect each other. That was fun. Again, not on your quiz, not on quiz, but it was a fun preview for what is to come, aka proofs. Woohoo! All right, I will see you all tomorrow.